Hello everyone. We'll continue our discussion about distance vector, and now we'll go through an example. Okay, so because it's easier to explain it in example. Okay, so we'll try to explain the iterative process in distance vector from time 0 until time 1, time 2, and so on and so forth. Okay, but we'll not try to finish everything because it will take a long time. Okay, a lot of process. But just assume that we have this topology A, B, C, D, E, F, G, H, I, and then each node has initially, so in T equals 0, so this, in the initial condition, all nodes have distance estimates to the nearest neighbors only. Okay, because as I said, this algorithm really depends on the neighbor. So initially, node A only has information a distance vector from A to itself, which is 0, and then A to B, which is 8, and A to D, which is 1. Okay, and all the other to all the other nodes is infinity. Okay, so some few asymmetries here. So for example, the link cost from A to B is 8, so it has larger cost compared to the other nodes. The link between other nodes, and there's a missing link between C and F. Okay, so after that, they basically each node has this same set of distance factor, and they will broadcast this. Each of them broadcast the distance factor to its neighbors, and then in the next iteration, upon receiving this broadcast from the neighbors, okay, each of them recompute distance factor locally, and then if there's any new change, and I think it's most probably will change the distance factor, then each node will again broadcast the new distance factor to its neighbors. And then this process again happens in the second iterations. All the nodes receive the updates of distance factor from its neighbors, and then it computes the new distance factor, and then again it notifies the neighbors about the updates of its local distance factor, and this process goes on and on and on. Okay, now let's have a look on details. Okay, in each and every iteration. So let's take a look at node B. Okay, so B receives distance factor from A, C, and E because they are the neighbor of B. Okay. So initially, B has distance factor only A, B, C, and E. From B to A is 8. Okay, it will be equals 8. From B to C equals 1. And from B to E equals 1. Okay, so we don't count the B to itself. Okay. Okay. Now, B receives from A, which has additional information. So basically, it has this A and B. But okay, there is new information about the new path. The A has the path from A to D, which is 1. Okay, and it is not there in B. And also C, there is no new information from C because C is only connected to B. Okay, and now E has a lot of, and it has more information because E has more links to the other nodes. So apart from connection to B, E has connection to D, and then to F, E to F, and to H. Okay, all has the cost of 1. So all of B's neighbors A, C, and E broadcast this information or send this information to B, and B has to recompute its own DV based on the new DVs received from its neighbors. Okay, so for the path to A, it knows that, okay, so from B to A is 8. Okay, and then from C doesn't have any information about the path to A, so it's infinity. And also from E doesn't have any information about its the path direct path from E to A, so it's also infinity. So in this first iteration, the least cost path from B to A is still 8. Okay, and now about the cost path to C. Okay, so A doesn't have a direct path to C yet at this moment, so the cost of the path from A to C equals to infinity. And the original, the original cost path from B to C is 1, which is already there. And from it, E doesn't have any direct path at the moment to C yet, so the cost path from C to E is infinity at the moment. And then the cost path from B to C is still 1. Okay, now we find new information, which is the cost path from B to D. Okay, so from A, B knows that, okay, so the cost from A to D equals to 1. Okay, and from the cost from B to A is 8. Okay, so the cost from B to D equals, if we go through A, then it equals to 8 plus 1, which is 9. If we go from B through C, okay, so C, so I think there's a typo here. From C to D should be, the infinity should be here, okay, because there's no direct path from C to D, and from B to E through D, from B to D through E. So the cost from B to E is 1, and the cost from E to D is also 1. So we get the cost path from B to D equals 2, and we have to go through to D, okay, through E, sorry. Okay, and then also we can find, okay, this E is the same as the previous iteration. There is no change about that. And F, so there is only one option to go to F, which is to go through E. Okay, so the cost from B to E is equals 1, and the cost from E to F equals 1. On all the other nodes, A and C doesn't have any don't have any direct path to F, so they have infinity. Okay, so the least cost path from B to F at this moment, at this iteration, equals 2, and we go through E, and then to G. Okay, from B to G, since there is no nodes that have direct connection to the direct link to G, either A, E, and C, so all the nodes have infinity, the cost of infinity. And then to H, there's only one option, which is through E. The cost from B to E equals 1, and the cost from E to H equals also 1. So the cost from B to H through E equals 2. And then finally, we don't have any direct path from A, E, and C to I. So we keep it infinity for this. So after this recomputation, then B updates its own DV, okay, and then B broadcasts its new DV to the neighbors, and this is done in the next iteration. Okay, so the next iteration, all the neighbors of B receive this update from B, and then it recomputes the DV, and then it starts again broadcasting the new information to its neighbors. Okay, so now let's take a look. Let's have a look for the composition at C. Okay, so C receives DVs from B because this is the only neighbors. Okay, so the only thing that it computes is the new path. Okay, from C to A, which was infinity, and then now with the new information from B, it knows that because the cost from C to B equals 1, and the cost from B to A equals 8. Okay, so now the cost is 9. Okay, and there is no update about the link cost path from C to B, and all the other nodes. Okay, also the costs from C to E, because B has direct path to E, so the cost path from C to B is 1, and the cost path from B to E is also 1, so the cost path from C to E equals 2, and all the other nodes are still infinity. Okay, now this is the new distance factor in C. All right, so at the end of the day, or let's say at the end of this iteration, the first iteration, um, all the nodes will have the new dv. And let's again take a look at the updates at happens at E. So since E has many neighbors, B, D, F, and H, so it will recompute the distance factor based on information received from its neighbors. So it has now new information about the cost path from itself to A. Okay, so there is two options to go from E to A, whether through D or through B. But if we go through B, then the cost path will be 1 plus 8, 9. And if we go through D, the cost path will be 1 plus 1, it's 2. Okay, so then the new cost path from E to A will be 2. And we go through D. Okay, now from E to itself is 0. Okay, to C. Okay, to C there's information that receives from B. Okay, from B it receives that there is the cost path from B to C, which is 1, and E already knows that the cost path from E to B is equals to 1. Okay, so now it can compute that the cost path from E to C equals to 1 plus 1, which is 2. And we go through B. Okay, so what else? Now D. Okay, we E get the information to go through G, whether it can go through D or through H, and eventually they have the same results, the same link cost path, which is 2. So we can update this with 2. And okay, so we can choose whether we can go through D or through H. And finally, to I, so the only link that provides this information is H, because it has this information. This is not C actually. There's typo here. Okay, so H to I equals 1, and E has the link cost path from E to H is 1. So basically, the new link cost path from E to I equals to 1 plus 1. Just 2, and we go through H. So that's it. That's it about this link cost path or a diffie calculation in each iteration. And actually we have to do it in each and every node for one iteration, and then second iteration, and so on and so forth, until we reach the convergence scenario. So I think that's it for the example. We'll continue about other aspects in distance factor, state information diffusion, and if there is link cost change in the distance factor. Okay, see you then in the next video.